Okay, this is a quick lesson reminding us about inverses, which we did talk about earlier in the year. So we have a quadratic function here, and I'm going to go ahead and graph it and see what the original looks like. I do know that this is going to shift it left 5, so I'm going to go 1, 2, 3, 4, 5 to the left, and up 2. I also know that from there, it's just a normal parabola, so I'm going to go over 1, up 1, over 1, up 1, and then over 2, up 4, and then over 2, up 4. So this is what the original function looks like. And I'm going to go ahead and just list over here the coordinates of the points that I just plotted for you. So I plotted the points -5, 2, that was the vertex, and then I got a couple points on either side of the vertex. So that's the original function. To talk about its domain and range, the domain would be all real numbers because there's no number that I can't square. In other words, this graph goes left and right forever. So the domain is just all real numbers. But the range, the graph doesn't start vertically until I get right to this point, and then it goes up from there. So the range would be the set of y's such that y is greater than or equal to 2. Okay. Well, you may remember to find inverses, all you have to do is switch the x and the y. So those roles are just going to switch. So literally, I'm just going to take my data table and I'm going to switch it. So 2, 3, 3, 6, 6, and then -5, -6, -4, -7, -3. So now I'm going to go ahead and plot those points. So 2, 1, 2, 3, 4, 5, and then 3, -6. -7. Okay. All right, so those are the points, and it would look like that. So you can see we end up with kind of a sideways parabola. And what it really is, you can see it's not a function. It does not pass the vertical line test. And that's because this did not pass the horizontal line test. So this is not a function. It's actually 2 pieces of a square root graph. But anyways, for the domain and range in this case, the domain doesn't start until we get to 2. So the domain is going to be the x's greater than or equal to 2. And you can see this y graph, this goes up forever and this goes down forever. So that means that the range is actually all real numbers. So you can see because we switched the x and the y, the role of the domain and the range also just basically flipped places. Great, so that's how you find an inverse graphically. You just switch the x and the y, and you may recall that this ends up being a reflection over the line y equals x. So this is going right through the points like 1, 1, 2, 2, and so on. This is the line y equals x. And this graph is a reflection. If I were to fold my whiteboard here over that green dotted line, the red and the purple would match up perfectly. So that's how you do an inverse graphically. So moving on to figure out how to do this algebraically, you need to switch the x and the y, and then get the y alone. So that's what I'm going to do. Notice this is the same problem we were just doing, but I'm going to switch the x and the y. And now I just need to do my algebra to get the y by itself. So first of all, I've got to get the squared thing by itself, so I'm going to minus the 2 to the other side. Then what I need to do is I can't get inside, you can't just like square and make that y squared plus 25 or something. I want to undo the square. So on both sides, I need to take a square root in order to do that. But you may recall from a while ago when we did square root equations, that when you take a square root, on this side, I need to do plus or minus. Because, for instance, -2 squared would be 4, and so would +2 squared. So you do need the plus or minus anytime you take the square root of both sides. On the right side, the square and the square root cancel. You don't need any plus or minus over here. You just end up with the y plus 5. So then what we end up doing is subtracting the 5, and notice that's after the square root. So you would end up with plus or minus the square root of x minus 2, and then minus 5. So we subtract that 5 over at the end. And if we go back to the graph, you'll notice that this is two square root functions, one positive, one negative, so one's a reflection. And this is going to shift right 2 and down 5. And if I go back to my graph over here, you can see that's exactly what happened. We went right 2, down 5, and then this is the positive square root, and then that's the negative. So we actually have the plus or minus because it takes two pieces in order to complete that full picture. Okay, now just showing you how I would put all of this into my calculator. I already did this. Here's my original function right here. And then if I want to type in that plus or minus square root of x minus 2 minus 5, it actually takes two different graphs or two different equations here, one with the positive and then one with the negative. And then I'm also putting in the y equals x just to show the reflection over that line. So I'm going to go ahead and graph this. And what you'll end up seeing, there's the original function. Here's the two pieces of that radical. It just because of the size of the pixels on the screen, you can't see where they connect, but they actually connect right here. And then you can see it folds right over that line, y equals x. Okay, so to kind of sum this up a little bit, an inverse is the relationship found when you switch the x and the y. So the roles of the inputs and outputs are switching places. And graphically, what that ends up being is a reflection across the line y equals x. And you will be responsible for knowing that information. So we're just going to try a couple more quick examples of finding an inverse algebraically. Basically, we're just switching the x and y and getting the y by itself. So, of course, f of x is the same thing as y. So this is going to be my x, and this is going to be my y. So first thing you do, switch the x and the y, and now you just use your algebra skills to get the y by itself. So I do have to add the 10 first. And then the next thing we're going to do is divide everything by 15. So there's a couple different ways we could do this. One is to simply write it like this. So we get y equals x plus 10 over 15. And that would be acceptable, but sometimes because this is actually a linear function, you might see it written in a different form. So on the SAT or something like that, you may see it written where we are taking that x plus 10 that we had up here, and everything needs to be divided by 15. So I'm going to divide both things by 15 like that. So I end up with x over 15. You can also write that 1/15 x. And then 10 over 15, of course, that's going to reduce to 2/3. So if I was to plot this, if I was to graph it, 2/3 would be the y-intercept. If you think of y equals mx plus b, and this would be the slope, right? Up 1 over 15. But the key thing is this answer and this answer are identical, although they look quite a bit different. So I just want to make sure that you're comfortable recognizing both versions of that. Okay, here's a similar problem. Again, to find the inverse, step number 1 is switch the x and the y. Right, so that's what I did. I switched my x and my y. Now to get the y by itself, first thing, we've got to get that 4 out of the denominator. So I'm going to multiply both sides by 4. And on the left side, I get 4x. That's fairly straightforward. And then on the right side, the reason why we multiplied by 4 is because 4 over 4 is a 1. So that's gone. And we're left with y minus 12. So now all I have to do is add the 12 to the other side. And that's my equation. It's a line. It has a slope of 4 and a y-intercept of 12. Just note that the notation that we use for inverses, we talked about this earlier in the year, is f with a little -1 like that. That means the inverse of the function. So just a reminder that that would be a better notation than just simply saying y equals. All right, in this case, I'm going to go ahead and graph the original function. I can see it's a quadratic, and it's just been shifted down 4, so I can do this by hand. 1, 2, 3, 1, 2, 3, 4. It's a normal quadratic, so the square root of 1 is 1, square root of 1 is 1. So I just went over 1, up 1. And then 2 squared is 4, so over 2, up 4, over 2, up 4. And that is the original function. So now what I'm going to do is switch the x and the y and try to get the equation for the inverse. So switch my x and my y. First thing you're going to do is get that y squared by itself. So get the squared thing alone. Anything on the outside you're going to deal with first. So I am going to add the 4 to the other side. And then I need to take a square root of both sides. So I'm going to square root both sides. But you've got to remember when you take a square root, you have to remember to put that plus or minus because you're actually getting two different pieces of the graph. And you just put that square root over the x plus 4. Because of the addition, you can't take the square root of 4 and turn it into a 2 or anything like that. So that's it. That is what the function looks like. And what that means is it's actually two different pieces. One piece is positive square root of x plus 4, and the other piece is negative square root of x plus 4. So if I needed to type this into my calculator to help me graph, I would have to type both of those in. But I think we can handle doing this by hand. So first I'm going to graph this piece. The plus 4 underneath means I need to go left 4. 1, 2, 4. 1, 2, 3. And it's just a normal square root. The square root of 1 is 1. The square root of 4 is 2. So over 1 up 1, over 4 up 2. And you'll notice that's only a reflection of part of the parabola. I need the other piece of it, which is this piece right here. It's just a reflection because of the negative. Remember, that's a vertical reflection. So I'm going to take my blue graph and just flip it vertically like this. And those are the two pieces. So the blue is the inverse of the red. And notice the red is a function, but because it doesn't pass the horizontal line test, the blue is not a function. It does not pass the vertical line test. And remember that this is a reflection across the line y equals x, which is this line right here. And if you're having trouble seeing that, I'll try to highlight what pieces kind of match up. This piece would fold over to this piece. This piece would fold over to this piece. This would fold over to this. So if I were to fold over the green line, that's kind of how the different pieces end up matching up. Okay, one last quick example. In this case, it's a cubed function, but we always start inverses the same way. So I switch my x and my y. Now, because there's nothing on the outside of the cubed function, the first thing I need to do is take a cube root of both sides. But because when you take a cube root, a negative times a negative times a negative is just a negative. It's not positive or negative. You don't put plus or minus when you do a cube root or a fifth root or something like that. So the left side will simply be the cube root of x. And then on the right side, the cube root and the cube cancel out. So we're left with 2y plus 5. Now from here, to get the y by itself, we have to subtract the 5. So you take the cube root of x, and then you just subtract 5. The 5 is after the cube root, so it's outside. And then the last thing you do is divide by 2. And once again, there's kind of two ways you could do this. You could divide the whole thing by 2 like this, or what you might see is each piece divided by 2. So I get y equals, and I'm just going to write f negative 1 of x, because again, that's the little bit better notation. This first piece right here, I could write 1/2 the cube root of x would be one way to write that. And then this next piece is minus 5/2. And again, you know how to put that into your calculator. So if I asked you to graph it, you just go to math and hit the cube root button. And you could type that in and graph it if needed.